This document is linked to the Statistics and Probability topic of the IB Maths course, and it's particularly looking at when you're working out the standard deviation, when you're trying to estimate from a sample the standard deviation of the parent population while you divide by n minus 1 and not possibly the more intuitive dividing by n. It goes on to explain what the whole task is and why you might be estimating a parent population. And then there's a few quiz questions for students to talk about with their neighbour in class. Then it goes on to building up for a simulation, and we're going to pretend here that we actually have a whole population, of data points, and there they are on show, rather conveniently normally distributed shaped. But we're now going to take samples from that distribution, and this final page here is the one where all the action happens. What's currently on show is I've got a sample of size 7 from that huge population you saw a moment ago, and I can change the size of that sample and it will just randomly pick another number of points from that data set. Now it turns out that because we knew the whole population, we actually happen to know the full standard deviation for that population, and it works out to be 5.89. But if I was going to use this sample of 7 data points and I use the normal procedure, but instead of dividing by n I divide by n minus 1, I would get the answer 3.51. If, however, I divided by n, I would get 3.25. So looking at all these different values, which one of them is actually closer, in this particular case, to the population standard deviation, and it's the value that comes from 3.51. So dividing by n minus 1 is a better estimate for the parent population standard deviation. Now if I choose this slider in the top left, I can pick a different sample of 7, and you can again see that the one divided by n minus 1 is a bit closer. And I can repeat the sample as many times as possible. Now at the moment they're always lying to the left of the red dot, and therefore the estimate divided by n minus 1 always seems to be better. But that's not always the case, and you might get a different sample of 7 like the one we have on show where dividing by n is better. And so what students can do is they can repeat the experiment, and you can see that they seem to flip-flop from side to side, but if you do it enough times and just tally this up on a piece of paper, you will find that in the long run the value from dividing by n minus 1 is generally a better estimate. But there is one small observation to make here, that often the difference between these two answers can be very little. At the moment the difference is only 0.3. But the difference between either of these answers and the actual true value can be very large indeed. So whether we're dividing by n or n minus 1, it's a small minor point or source of error when thinking about what the true value might be, because we could always be well above it and well below it, and ironically we never know what the true value is, and we're just going by these estimates. So the following pages in the document give a student an opportunity of just recapping on the formulas they've done and the process that's going on in the whole activity. But they have complete control over the sample size, and obviously the larger the sample size they go to, the smaller the difference is. I mean, this one's dividing by 20 and this one's dividing by 21. The 2 points get closer and closer together, but still they can be quite a significant away from the parent population standard deviation. So this gives students a sort of hands-on simulation. This works particularly well if you're using a navigator system, and you can project up on the display at the front of the board all of the class's simulations results and see if the majority have n minus 1 giving the better estimate. That's it. That's all it